Alright, hopefully by the time you get to this video and you're searching at things, you already know how to find perimeter of a figure if you're given all the side lengths already. So if you're given a shape, let's say for example a triangle like mentioned here, if we had a triangle that had side lengths of 3, 5, and 9, the perimeter here would be 9 plus 3 is 12, plus 5 more would be 17. So we say our perimeter is 17. In this problem, though, we've been given the vertices and their locations on the coordinate plane. This is a little different. So if you've seen the previous video on the distance formula, you're going to be able to use that here to help you out. What I would suggest anytime you have a coordinate plane problem, anytime that you're given a set of points to create a figure, a shape, please sketch the figure. So let me scribble this right here. That was just kind of a little side note. What I'm going to say, though, is that you don't have to be super accurate on your sketch, because more often than not, you don't need graph paper for a problem like this. It's rare that they give you points that are just so nice that the graph paper actually helps. What I want to do is just look at the x values here. I see 2, 3. So I'm just going to put a point. I'm going to say this is 2, 3. And then 4, 7 would be to the right a little bit and then up a little bit. So let's just call this 4, 7. And then 6, 5 is even further to the right, but it's halfway between these two guys. So maybe somewhere like here. Let's just call this the point 6, 5. So we have A up here, we have B down here, we have C over here. So our triangle, just roughly, something kind of like this. Notice that I don't really care if this shape is super well drawn, because that's not what they're asking me to do. They didn't say draw a perfect sketch of this triangle. They said find the perimeter of the triangle. Now, thankfully for a triangle, the diagram isn't as necessary. But for shapes that are bigger, trapezoids, pentagons, anything like that, if they go in and give you more than 3 points especially, you're wanting that figure drawn because some shapes, for example a square, if you don't draw it, you might accidentally use the length from this point to this point on this diagonal. You may accidentally take, like, let's say this is A, B, and C, and then D over here. If you're just picking random points, you might go, oh, I'll just find the distance from A to C and then from B to D, and you'll find too much information and you'll end up with things that you don't need in the problem. So sketch it out first and then go, okay, I'm going to find this side right now, and then this side, and then this side. In fact, let me call this side 1, side 2, and side 3. I'll use S to represent that. When we looked at the distance formula, we said that it was very simple to go in and, actually let me jot that up here, and take our points. We'll take our x values and subtract them, and then we'll take our y values and subtract them, and then we just square both of those differences, add them together, take the square root of that. This is a big Pythagorean theorem type problem. But for this, otherwise, if you can get past that, if you know that the distance here is just using the distance formula on these points, then this is going to be very simple. I'm going to go in and do 4 minus 2, that's my x values being subtracted. I'm going to do 7 minus 3, which are my y values being subtracted. And I'll be able to get the distance for S1. For S2, I'm going to do the same sort of thing. But for S2, I have 6 and 5 instead of 4 and 7. So instead of 4, we have 6. Instead of 7, we have 5. And there we are with that one. And finally for S3, and I know I'm going a little quickly here, but this is very repetitive. That's the downside to a problem like this. These are some of my least favorite problems, actually, just because they end up feeling very tedious. There's a lot of just repetitive motion going on. The 6 and the 5 we're going to keep the same. We're looking at the C, but we're going to switch the 2 and the 3 to reuse the 4 and the 7 now. So 6 minus 4 squared plus the 5 minus the 7 squared. And you might go, well, wait a second, that one's going to give me a negative number, and that's okay. We're going to be squaring that value out here, so it's going to become positive again anyway. And you could flip the order on that and it wouldn't matter. As long as you pair your x's together and you pair your y's together, you're in great shape. Now, I'm going to grab a calculator because I want to illustrate something. And what that is that you don't have to necessarily go in and find these individual values. you can, and here it would be super simple. There wouldn't be a problem. These numbers are small. But if they gave you larger numbers that would take you a moment, then what you can do is just type all of this in the way it's written. I'm going to do 4 minus 2 squared plus, and then in parentheses, 7 minus 3 squared. That's my S1. And I go, okay, easy enough. We're getting about 4.47. Now, I personally think that rounding to 2 decimal places is better here, just because this is going to be very inaccurate otherwise. And so then we'll just keep running these down. 6 minus 2 squared plus 5 minus 3 squared. And I'm only doing it this way to illustrate that you can do it this way. Realistically speaking, I'd expect you to realize that's 4 squared and 2 squared. That's not too bad. And then here's 6 minus 4 squared and 5 minus 7 squared. Always double checking to make sure we've plugged things in correctly. So looking at that, that all feels pretty good. So we're going to go in and say we had 4.47. You'll notice that these first two ended up being exactly the same. The last one rounded up to 8.3 there. There was an 8 after the 2. You might ask yourself, why are these two the same? But if you really think about it, there's an equitable amount of distance between a lot of these points. They're all related in some way. So you may go, well, what do you mean by that? Just keeping in mind that these things are distanced very similarly speaking. So this is the same distance away vertically, and that sort of thing. It kind of seems like it could parallel itself there a little bit. But all we're going to do now is say, well, look, we're looking for the perimeter, so let's just add up all of these sides. We're going to add these three numbers together, so just put a little plus sign on these guys here. And we'll actually just go ahead and be a little lazy and just grab this calculator and say 4.47 times 2 plus 2.83. Now notice I didn't add these two together. I said this times 2 because multiplication is repeated addition or a repeated number. This number is happening twice, so just multiply it by 2. And we get about 11.77 for the perimeter of this thing. We'll just say 11.77 units because we don't have a unit of measure given.